Okay, so for this particular question, the reason why I want to go over this is because we didn't get a chance to go over something like this one, like f minus g of x, and then we have to draw it on the same pair of axes, same set of axes. So what we do, we could set up a little table actually, and the way we do that, it's by having we're going to look at some x values. Okay, so we have some x values, and then we have the f of x, and then we have g of x. And then on the third column, we are going to have f minus g of x right here. Okay. All right. So, so now, what kind of x values we are going to put in here? We are going to put in some notable ones. And what do I mean by notable? Now, since these are all straight lines, so we could do one thing that makes our life easier. We'll just say, all right, you know what? Just go ahead and get all the x values that either graph would show you a change of direction. Okay. So I'm going to focus on -5, -3, and then -1. Okay, see right here, they're changing the direction. And then we have 0, it's changing direction over here. And then I'm going to put them 1, 2, 3. And then the last one will be 4. Okay, again, I'm picking these points because if you look at, well, -5 would be the starting point. -3, it's where it bends right here for g of x. And then -1, it's where both change direction here. And then you have 0 when f of x changes its direction. And then you have x equals to 3 when the f function changes direction. So what you do, it's very simple. Okay, you just go ahead and extract what f of -5 is. F of -5 is 3. G of -5 is -2. And then you're subtracting these two numbers. And we say, well, okay, what's 3 minus -2? That'll be 5. So you would put a point here at 5. Okay. And then you do the same for x equals to -3. F function would be 1. G function, g of -3, it's -1. And 1 minus -1 would be 2. So we put a point right here. And you can connect them together. And you do the same thing for x equals to -1, which would be -1 right here. And then you have -3. So 1 minus -3 would be a 2. So it stays flat. Okay. Now I'm going to pause a moment and ask, is there any question on what we're just doing for these past 3 x values? Are we good? Okay. Now, if you're good, I want to also bring you one additional layer of understanding. We can ask a question right here and say, hey, look at here, it's flat. Is it okay to be flat right here? Should it be flat right here? Then we're saying, well, then we need to ask, wait, hold on, what is this graph? The new graph that we're making, what is the meaning of it? Well, it is f minus g, right? So that means it is the distance between f and g. Then we say, well, if you look at here, can you see the difference, the distance right here between these two lines? Do you think they keep the same distance? Well, that's why it is flat. Okay, so that's what it means. Okay, f minus g is really just describing the distance between the distance between the two functions right here. So it makes perfect sense that it's a flat zero slope segment. And then we say x equal to 0. So f function would be a 2. G function would be a -2. And that would give you a 4. And can you see that the distance between these two lines is a distance of 4? Okay. So again, what you're plotting, it's representing the distance between the two functions. And then when x is equal to 3, right here, this is equal to what? Still 2. And then this is a 1. So therefore, 2 minus 1, it's a 1. Okay, so you can see the graph declining. Okay, it's decreasing because the distance between f and g, it's actually decreasing. Okay, from 0 to 3. And then when you have a 4, you have 1. This is 2. You have a negative 1. So that means it goes down because now a function f, it's 1 unit below g of x. Therefore, you have a negative 1 right here. So that's how you can easily create this graph. Okay. And now, any question about the creation, the generation of this graph? Okay. And then we say, all right, what is the relative maximum? So can you see the relative maximum on this graph? Okay, so on this graph right here, can you see the relative maximum? Okay, this would be your relative maximum right here. And this relative maximum will be 4 when x is equal to 0. Okay. So again, relative maximum, the word itself gives you the hint, it's relative, okay? So so the numbers around them should be lower than this particular point. And that creates the relative maximum. Yes?
Why is negative 5 not the relative maximum? Because it also has numbers.
Okay, good. Now, when we look at negative 5 comma 5, okay, so we're looking at this point in particular. Now, this will be what we call absolute maximum, actually, because it is absolutely the highest point of the entire graph. But we don't call it the relative maximum because, you know, in order to have a relative maximum, again, it has to somehow go up and down. And since it's the endpoint, it didn't really go up. It just begins to go down. So that's why we don't call that starting point a relative max, but this is FYI, that's called the absolute maximum for sure. And since you ask, and I would also say that this point right here, we call this the absolute minimum. Okay, this is the absolute minimum because this is the lowest point of the entire graph. Ah, good question. Do we have a relative minimum? Do we? What would you think? Yes? Yes? Which part? Yes is correct. Good. This part, okay, this region, okay, with all the x values there, would be considered as the relative minimum. Okay, because relatively, it's the lowest point. Okay, even though it's flat, okay, we have quite a few points here that will be considered as relative minimum. So that's a very good observation. Okay. So it will be on the quiz or on the test. Okay, so something that you should be able to handle. Okay, so we are equipping ourselves with some skills, and this is just about reading the graph. Can you read the values from the functions, okay, respectively, and then handle the addition or subtraction as a result?